Day 240 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we made it all the way to day 240 and we're still going strong. Today we have question number 102, binary tree level order traversal. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand as possible. So let's get into it. The question says, given the root of a binary tree, return the level order traversal of its nodes values, i.e. from left to right, level by level. So let's look at example 1 so we can see what it is that they're talking about. And just by the title, binary tree level order, we know that we're going to have to traverse level by level, which means we're going to have to use a breadth first search traversal. So let's see what the input and the output is so we can figure out how we're going to do that. So in the input, we have the root equals a binary tree, 3, 9, 20, 0, 0, 15, and 7. Excuse me, y'all, which is represented by this picture right here. Then the output is 3, or it's a 2D array. First array is 3. Then we have second array is 9 and 20. Third array is 15 and 7. So by looking at this picture and this input and output, we can tell that all they did was in the output created a 2D array. The first array in the 2D array is the root node. Second array is the first level, boom, of the binary tree. And the third array is the second level of the binary tree. Boom, just like this, just like so, right? It goes one right here, then we go here, here. Boom, and that's all they did. So let's look at example 2 in case they try to throw some trick questions our way, where in example 2 we only have one node, the root node, which would be 1. The output would still be 1 because there's only one level that we have to traverse. And similar in example 3, we have the input root equals a blank array. We could just return another blank array because that means there are no nodes to traverse. There is no binary tree to traverse through, so we could just return a blank array and just keep it as nil because it started as nil and there's nothing there. So now that we understand the question, y'all, let's get into the solution. But before we get into the solution, y'all, don't forget, if you need any new Apple AirPods, go ahead and check that link in the description. And then after you do that, go ahead and like, comment, and subscribe. Y'all, it's just a click of a button. Just go ahead, hit that like button and hit that subscribe button for me. And then drop some bank emojis in the comment section for me, y'all. Now, let's get into the fun part, the actual solution. Not that difficult. Like I said, we're going to do a breadth first search traversal. So let's get into it, y'all. So first thing we need to do is we need to check if the tree is empty, right? And if the root is nil, that means we could just return an empty array like they did right here in example 3. So in order to do that, all we have to do is start with the guard statement. We're going to say guard let node equal root, else we're just going to return a blank array, right? Because if there's no root, then there's nothing to traverse. Now we need to initialize an array to store the result where this each subarray will represent a level, each level, right? So we need to create our 2D array and a variables that we can store that data in, right? So we are going to declare a variable by saying var output colon. This is going to be our 2D array, so we can say 2D array of integers, and then we're just going to initialize it with a blank array like so, right? Now we need to initialize a queue for our breadth first search traversal, y'all, and it's going to start with the root node. So in order to do that, we're just going to say var queue colon, open up the square brackets tree node, and we are going to just start it with the root node, right? By saying open up the square brackets and saying node. Boom, just like that. Now we need to start our traversal somehow, right? So we're gonna say while exclamation point q dot is empty, which means while q is not empty, what we are going to do is, first thing we need to do is create an array to store the values of the nodes at the current level. So whatever current level we are, we need an array to store the values of those nodes at that level, right? So We could do that by declaring a variable called nodes in current level, boom, colon, open up the square brackets, integers. It's going to be an array of integers, and we're going to initialize it with a blank array like so, right? Now it's time to iterate all of the nodes at the currently in the queue, right? Or the nodes at this level. So in order to do that, we are going to say for tree node in queue, boom, open up the brackets. First thing we need to do is we need to remove the first node in the queue for processing, right? So we could just say queue dot remove first, boom, just like that. Now we need to see if the node has a left child. We need to add that to the queue for the next level. So in order to do that, we need to say if let left equals tree node dot left, open up the brackets, queue dot append, open up the parentheses, left. So what this is going to do is it's going to check to see if the node has a left child or a sub or right. We need to do the same thing for the right child, but it's going to check the children of each node so we know which nodes are on the next level, right? So now we need to do it for the right child. So we're going to say if let right equals tree node dot right, open up the brackets, queue dot append, open up the parentheses, right, just like that. Now we need to add the value of the current node to the list of nodes at this level, right? So that's where we are going to append the values to this array that we created up here, nodes and current level. So in order to do that, we're just going to say nodes, nodes and current level dot append, open up the parentheses, tree node dot val. So once again, that's going to add the value of the current node to the list of nodes at the current level, right? So boom, now what we need to do is we need to come outside of this for loop, boom, just right here. And after processing all of the nodes at the level, we need to add their values to the output array. Because don't forget, the output array is what is our 2D array of each level, right? So now we need to add the nodes from the current level to the output array. So we're just going to say output dot append, open up the parentheses, nodes and current level, boom, just like so, right? Now we just need to come down here and we need to return the output. So we're just gonna say return output, boom, just like that. Now let's run it, see how it runs. You know how this stuff can get. Okay, so cannot find node and current level in scope. So it's a typo, so it should be nodes. Sorry about that. Now let's run it again. Okay, it's accepted. So now let's submit it. Make sure it stays accepted, y'all. Let's see. Oh, ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. Those some good numbers right there. That's what I like to see. That's some good numbers to go with a good, simple solution, y'all. So make sure y'all look at this solution. Look at the solution one more time. Read it, learn it, love it. You know what I'm saying? It's not that difficult to understand. It's pretty self-explanatory. We're just doing a breadth first search traversal. Remember, that's level by level. We're traversing the binary tree level by level. And yeah, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.